Alright, now we are going to discuss some problems related to the motion with constant acceleration. This is the first one. Two cars A and B are 1000 meters apart and they are moving toward each other. A accelerates 10 meters per second square from rest, and car B initially moves with a speed 20 meters per second and accelerates 5 meters per second square. If both cars start to move at the same time, find the time and the distance for them to meet each other. Let's now discuss the first problem. So we have two cars A and B, and A starts from rest and it accelerates 10 meters per second square, and B start with initial speed 20 meters per second and it accelerates 5 meters per second square. So at the end they will meet. Let's imagine they meet here, and this is A, B, and the distance traveled by A here, let's call distance A dA, and the distance traveled by B here, let's call it distance B or dB, and their initial distance here is 1000 meters. So first, let's see how this distance is related. So you see that here 1000 meters is equal to the distance traveled by A dA plus the distance traveled by B dB. And now let me remind you again, if we have an object, let's say it has initial speed v0 and its accelerate A. So after it moves t second, the distance traveled by the object will be v0 times t plus 1/2 times a t square. So now we can continue that 1000 meters is equal to dA v0a times t plus 1/2 times acceleration of a times t square plus v0b times t plus 1/2 ab times t square. And let me write in here 1000 meters is equal to, since A starts from rest, so the v0 of A is 0, and then plus 1/2 times 10 times t square plus, here the initial speed of B is 20 times t plus 1/2 times 5 times t square. So after we put these numbers, we can solve now that we get an equation 5 times t square plus 20 times t plus is equal to 1000, and if we multiply by 2, we get 15 t squared plus 40 times t and minus 2000 is equal to 0. And next we can divide by 5 so that we get, of course this is just mathematical problem actually, and you get a quadratic equation. And to solve this quadratic equation, you can use any technique. Here I will use the ABC formula so that the roots of this quadratic equation, or in this case the time, here is minus 8 plus minus square root of 64 minus 4 times 3 times minus 400 divided by 2 times 3, and we use the plus solution. So if we calculate, we will get 61.74 divided by 6, and here the time when they meet is 10.29 seconds. So if we calculate the distance traveled by A, then you get 1/2 times 10 times t squared, and by putting the time here 10.29, you will get 529.5 meters. And if we calculate the distance of B, so distance traveled by B here is 20 times t plus, and by plugging this number here, we'll get that the distance traveled by B is 470.9.5 meters. So let's see again our picture here, and you already calculate that the distance traveled by A is 529.5 meter, and the distance traveled by B here is 470.5 meter. So the total distance of both cars will be 1000 meters. This is the second problem. Two cars P and Q are moving in the same direction. They are initially 100 meters apart, and Q is in front of P. P accelerates 10 meters per second square from rest, and Q moves with an initial speed 20 meters per second and accelerates 5 meters per second square. If both cars start to move at the same time, find the time and the distance when P passes Q. Let us now discuss the second problem. So we have two cars here, P and Q, and they are moving in the same direction. And P starts from rest and it accelerates 10 meters per second square, but Q has an initial speed 20 meters per second and it accelerates 5 meters per second. So at the end, P will catch Q at a certain point. Let's say this is the place where P catch Q. Now let's divide let's define the distance traveled by both cars. So the distance traveled by P here is distance P or dP, and the distance traveled by Q here is the distance Q, dQ. And remember that initially they are 100 meters apart. Now let's see how these distances are related. So you have 100, you have distance Q, you have distance P, so that you will see that the distance P here is equal to 100 meters plus distance traveled by Q. Alright, now let's define every distance we have here. For example, for P, it will be 0 times t plus 1/2 times 10 times t square. And the distance traveled by Q here is the initial speed 20 times t plus 1/2 times 5 times t square. Okay, now let's put these numbers into here so that we get 5 times t square is equal to 100 plus 20 times t plus so if we calculate here, we get now again we have a mathematical problem like this one. This is a quadratic equation, so that we can solve this. Now I will multiply by 2 so that we get 5 times t squared minus and I will divide this by 5, so I get t squared minus 8 times t minus 40 is equal to 0. So now we have a quadratic equation. It's t squared minus 8 times t minus 40 is equal to 0, and we can solve this using a ABC formula. So we'll get that t here is 8 plus minus square root of 64 and we use the positive sign, so we get 8 plus divided by 2, so we get that the time P catch Q will be 11.48 seconds. And if we calculate the distance traveled by P, it will be 659.33 meter, and the distance traveled by Q will be here 500. So if we take a look on previous picture here, the distance traveled by P is 659.33 meters, and the distance traveled by Q 559.33 meter, so that you see that satisfies this relation. This is the third problem. A car accelerates a1 from rest, and after it reaches a maximum speed, it decelerates minus a2 until it stops. If the total traveling time is t, find the total distance of the car. Let's now work on the third problem. So here we have an object that starts from rest, meaning that the initial speed is 0, and it accelerates a1 until it gets a maximum speed, let's say it's Vmax, and then it decelerates, let's say minus a2 until it stops. So the total traveling time from the beginning until it stops is given, it's t. Now we are asked to find the distance. So now let me draw for you a speed versus time, so you will see this problem clearly. So now the object starts from rest, that means the initial speed is 0, and then it accelerates until it gets the maximum speed. And then it decelerates until it stops. So the speed is 0, and the total traveling time here is t. Now we can see, then you already learned that if we have a speed versus time graph, the area under the graph is the distance. So here we can find that the distance traveled by this object will be the base t times the height here, Vmax, divided by 2. Now we will calculate the distance from here, but we need a help. What I mean by help is, let's say the time needed from the beginning until it gets to V maximum is t1. So the time from here to here, this is t1. Now you can define the acceleration a1 to get what Vmax. So a1 is the acceleration here. That means if the final speed is Vmax and the initial speed is 0, then a1 is Vmax minus 0 divided by t1. And now it decelerates a2 minus a2. So minus a2 is the final speed here, 0, minus, now the initial speed is Vmax, but the time here is this one. So that's t minus t1. So that's t minus t1. The problem we have here to find the distance is that we actually still do not have the value of Vmax. So by using these two equations, we will find the value of Vmax. Now let us write this equation here, the first one. So I will substitute t1 here. So t1 is Vmax divided by A1. And the second equation, let's write again like this. So A2 is equal to Vmax, so minus and minus disappears, divide by T minus T1. And we can also rewrite like this: T minus T1 is equal to Vmax divided by A2. So now let's substitute T1 here, and we get T minus Vmax divided by A1 is equal to Vmax divided by A2. So the T here is Vmax divided by A2 plus Vmax divided by A1, or T is Vmax times 1 over A2 plus 1 over A1, and T is equal to Vmax times, this is A1 plus A2 over A2, A1, so that Vmax now is T times A2, A1 divided by A1 plus A2. And finally, let's see the distance. We have the distance is T times Vmax divided by 2, and then the value of Vmax here is T times A2 times A1 divided by A1 plus A2, so that's Vmax divided by 2. So we get that the distance traveled by this car is A1 times A2 times T squared divided by 2 times A1 plus A2.